Hello, and welcome to Argument Basics. In this video, we'll take a look at inductive arguments once again. So inductive arguments, shockingly enough, are arguments, which means that each inductive argument has a conclusion, the point you're trying to argue for, the point you're trying to establish, the thing you're trying to prove. And you prove or support this conclusion by offering one or more premises, the evidence or reasons given for that claim. Now, the hallmark of inductive reasoning is this. Inductive arguments are such that the premises are intended to provide some degree of support for the conclusion, but not complete support. What does that mean? Well, it means that when you're making an inductive argument, you're offering premises as evidence that the conclusion is, at best, probably true, that it's likely to be true of its good reasoning. Now, two good questions here. One is, why would people use these arguments if they only deal with probability? Why not just always go deductive? And as you recall, deductive arguments deal in certainty. If you have a deductive argument doing what it's supposed to, that is to say, valid, that means if you put in true premises, you're guaranteed a true conclusion. So why ever use inductive reasoning? A second good question is, why are they like that? Why would the premises not guarantee the truth of the conclusion? So to answer these questions, first, in terms of why we use them, the reason is because sometimes it's the only option. Because although ideally we'd want to always use deductive arguments, they don't always work in practical situations. Now this ties into the second question, which is why are they like this? And this also ties into why we do it this way, why we ever use them. And the answer to the second question, why are they like that? Well, it's because when we engage in inductive reasoning, we are going beyond our evidence. We're doing what in the philosophy business they call the inductive leap. We're going beyond what we've observed, drawing a conclusion to what we haven't observed. And the reason why this makes it such we can't be sure is because, well, if we haven't observed, all of it, then we could be wrong. And tying back to the first question, why use them? Well, in much of life, that's how it works. We're going beyond our evidence because we just don't, for practical reasons, we can't, see everything. So, quick illustration. One example is with polls and surveys. This is just a matter of numbers. So, as this is being recorded, the 2024 election is, approaching, and the candidates are fighting to see who's going to be the nominee for each of the parties. Now, the news agencies, of course, in the political parties want to have an idea what's going on. But of course, they can't ask all the millions of voters because that would take too much time, cost too much money. So what they do is they take a sample. So they poll, say, 1,000 people or 1,500 people and ask them, if the election was held today, who would you vote for? Now, the reason why they do that is because, again, practicality, money, time. Now, because they've only polled, say, 1,500 people out of millions upon millions of voters, you can see why they could be wrong. The people they poll might be different from the people they did not poll. So you're leaping from the people in the sample to all the voters. And there could be a difference, and there's an inductive leap there. But obviously, since, we're not going to spend millions of dollars on polling and poll everybody, we use the inductive reasoning because of practical concerns. Another example, the future. So we make predictions about the future, but of course, unless you're a time traveler, you've not, or have prophetic powers, you've not seen the future. So we believe that the future will be like the past. But as David Hume, who is a guy who came up with this problem, pointed out that when you're going from what you have observed to what you haven't, you could be wrong. And the future provides a pretty good example. Just because something was a certain way in the past doesn't mean it'll be that way in the future. A good example, they always say, if you've ever seen commercials about, investing in stocks, they put in a warning essentially that past performance doesn't guarantee future performance, that what was doesn't have to continue to be. And so when we make predictions about the future, we can always be wrong. And the reason why we use inductive reasoning is because, well, as far as we know, that's the only way to do it. We can't do, make deductive arguments sensibly about the future. Now, this is known in the philosophy biz as the problem of induction. Hume didn't call it that, but he's attributed with this problem, and then people started calling it in philosophy. And it's a problem that, given that you're leaping from what you've observed to what you haven't observed, how do you know that that's going to be correct? And how do you justify inductive reasoning? And Hume argued, I won't go into the details, but Hume essentially argued you can't be sure about what you haven't observed, and so you really can't be confident about induction. But then he was kind of practical. He basically said, hey, don't worry about it, go get a beer. But anyways, if you want to know more about David Hume, philosophy classes, specifically modern philosophy. So inductive arguments, quick recap there. So inductive arguments are arguments in which the premises are intended to provide some degree of support, but less than complete support for the conclusion. They deal in probability, that the premises are given in the hopes that they'll make the conclusion likely to be true, as opposed to certainly true. We use this because, hey, sometimes it's the only option. And the reason why they're like that is because we're going beyond our premises. We're making a leap, say, from the past to the future, or from, more broadly, from the observed to the unobserved. So how do you tell when you've got a good inductive argument? So in general terms, like we saw in a previous video, like any argument, you would raise the general question, is the logic good? How well do the premises support the conclusion? Now, in the case of deductive arguments, as we saw, one pretty good feature, depending on how you feel about, truth tables and stuff, is that deductive arguments can be tested with certainty. You do a truth table, you do a proof or a Venn diagram, and as long as you do it right, you'll know whether it's valid or invalid. So it's kind of like if you were, getting the results of like Olympic track and field. It's just numbers. How far did the person throw the discus? How high did they jump? How fast did they run the 400 meters? And the fastest time wins, the longest throw wins. Just objective, straightforward. Now, continuing our sports metaphor, inductive arguments are kind of like judging, say, the figure skating or dressage. And I learned about dressage back in 2012 when Mitt Romney was running for president, and he owned a dressage horse. And there is a dressage event at the Olympics. And put kind of stupidly, it's horse ballet. Now, if you're judging dressage or Olympic figure skating, it's not a matter of like speed or distance. So there's not like numerical, values you're reading on, a clock or measuring tape. Instead, there are standards that are applied, but there's a degree of, you might say, subjectivity. So two people assessing the same figure skating performance can disagree in a principled way. Similarly with inductive arguments, they have not like set, truth table tests, etc., but they have standards that you apply to judging them, like you would judge, say, a dancing contest or, music contest or an art contest. And there are standards that you would apply, and then you judge them based on those standards to assess whether they're strong or weak. And because of this, people in good faith can disagree in their assessments, which makes inductive arguments even more messy and complicated. So a strong inductive argument is one such that if the premises are true, then the conclusion is likely to be true. How likely? Well, fortunately, in various science fields, etc., they do have set numbers. So, for example, the gold standard is like, roughly put a confidence level of 95, which kind of crudely is put as like saying if the argument's built properly, is a 95% chance that it's going to get things right. And so like in the sciences and polling, they usually aim for that level of confidence. Now, in informal everyday reasoning, like if you're judging whether your friend is likely to show up on time to take you to the airport, you're typically not going to assign like an exact number. You'd kind of judge if your question is, will my friend arrive on time to take me to the airport? You would use evidence like their past reliability, dependability, reliability of their car, etc. And you have kind of an informal confidence in them. So, strong argument, the conclusion is probably true. How probable? Well, again, it depends on the purpose, and how you're measuring it. Weak arguments are ones that they're such that even if the premises were true, because of the way the logic is, the conclusion is not likely to be true. So it's probably going to be wrong. And again, this can range from like exact numbers, like with sciencey stuff, or rough estimates like in everyday life. To give a quick example, kind of silly example, but suppose you're trying to predict the eye color of the next person you see. You're random, like suppose imagine we're like in a classroom and people are walking in. Now, apparently about 80% of humans have brown eyes. So a good guess would be brown eyes, unless you know the person coming in, of course. So if I say 80% of humans have brown eyes, the next person coming in the class will have brown eyes. In that case, it's a pretty strong argument because there's an 80% chance I'll be right. And I could still be wrong, of course, because humans come in a variety of eye colors, but brown would be a good guess. And that would be a fairly strong argument. Now, if I was trying to guess, say, whether the next person through the door was a male or female, then this would be about, say, roughly 50-50. And so if either way I guess, then my chance of being right is a coin toss, essentially. And so that would be a pretty weak argument. Now, as a final example, we're talking about, say, left or right-handed. Most people are right-handed as opposed to left-handed. So if I bet, the next person to the door would be right-handed, probably right. But if I bet the next person to the door is going to be left-handed, probably wrong. And that would be a weak argument because most people are not left-handed. So those are the basics of inductive reasoning. So there are arguments, of course, so premises, and one conclusion. They deal in probability rather than certainty. They're assessed in terms of particular standards for the arguments. We'll see some of these in the future. If they're good, then they're strong, which means that if the premises were true, the conclusion is probably true. And if they're weak, that means they're logically such that if the premises are true, the conclusion is probably not likely to be true. Now, as a closing point, just like validity doesn't mean true, strong also doesn't mean true. You could have a very strong argument in which the conclusion turns out to be false. Use a simple example. Go back to handedness. A huge percentage of people are right-handed. Very few people are left-handed. And so that's a very strong argument. If I say the next person, coming into the classroom will be right-handed, very strong argument. But the next person could be left-handed. The argument would still be a strong argument. I just would have gotten the result wrong. It doesn't make the argument weak. It just means, to use a dice metaphor, I rolled badly. I didn't get the right answer. And a weak argument, of course, argument could be weak, even though the conclusion is not likely to be true. You could still have a weak argument with a true conclusion. Because again, it's not about whether it's true or not. It's about the logic. So if I say the next person through the door is going to have, be left-handed, that's a weak argument because they're probably not going to be left-handed. And if the person comes through in the left-handed, well, I was, lucky. I got it right, or rather I got it left. And so the argument was still a weak argument. It still wasn't good reasoning. It just happened that, lucky roll, to use a dice metaphor. So again, strong doesn't mean true, weak doesn't mean false. It's a measure of the logic. You can have a strong argument where you get the conclusion wrong, because that's induction. You can have a weak argument where the logic is, not good, but you get it right. Again, that's also how induction works. So that concludes our brief look at inductive arguments, and I'll see you in the future.